In this video, we are going to talk about example 9.8, which is about Formula One racing. If you watch a Formula One race, you can see that the race cars approach curves from the outside, cut through the inside, and then drift again to the outside, as shown by the red path in the figure. The blue path is shorter. Why don't the drivers follow the shortest path? The problem is asking us, suppose that the car moved through the U-turn at a constant speed and that the coefficient of static friction between the tire and the road is mu s, which is 1.2. If the radius of the inner curve shown in the figure is rb, 10.3 meter, and the radius of the outer is ra, which is 32.2 meter, and the cars move at their maximum speed, how much time it will take to move from point A to A prime and from point B to B prime. So question is asking us how much time will the car take to move from A to A prime here and B to B prime here if they are both moving at their maximum speed along these paths. So let us first write down what is given to us. We have the coefficient of static friction, which is mu s, 1.2. Then we have the radius of the inner path or the shorter path RB, 10.3 meter. And then we have the radius of the bigger path or the outer path RA, 32.2 meter. Now, if you want to calculate the time t it takes for the car to move along the red path and the blue path, all you need to do is know what is the distance they cover along this path over the speed with which they were traveling. So if I can find the speed v and the distance l that they covered, I can calculate the time taken by the car moving along the red path and the blue path. Let's start with the speed. If I want to find speed with which each car is moving, we need to first understand the forces that are acting on them. So we draw a free body diagram for these forces. Suppose this is the curve and we have the car moving along the curve. The first force acting on the car is the force due to gravity acting vertically downward. So we draw Fg acting down. Then we have the normal force, which is perpendicular to the surface, acting opposite to gravity. Then we have the force of friction that acts towards the center of the curve. I will call it small f. Once we identify the forces acting on the car, we will write the equation of forces along x and y axis separately. Since there is no acceleration along y-axis, the net force acting along y-axis we can write to be equal to 0. And if the net force along y is 0, when we add all the forces along y-axis, we get the normal force minus the force due to gravity to be equal. Or we can write the normal force to be equal to Fg when we move Fg to the other side. And Fg, we know it is equal to m into g. So normal force is equal to the force due to gravity numerically, which is m into g. We do the same thing for forces along the x-axis. The force of friction points towards the center of the curve, and it is the force of friction that is providing the required centripetal force to keep the car along the circular path. So along x-axis, we will equate the force of friction to the centripetal force Fc. We know the force of friction can be written as mu times n, that will be equal to Fc. And mu times n can be written as mu mg, because here in the first part of the equation, we said that the normal force is equal to force due to gravity, which is equal to mg. And for centripetal force, we write it as mv squared over r. I'm choosing this expression because we need to calculate what is v. Then we rearrange the term and cancel off the common quantities here. M is common here. And we can rewrite this equation as mu g equals v square over r. Then we rearrange the term. V square is equal to mu gr, or v equals square root mu s g r. So this is the expression for speed, the maximum speed with which the cars can take turn. And we will use this expression to calculate the speed of the car moving along the red path and the blue path. So along the red path, the radius of the curve is RA. So we write VA for that equals square root mu s g RA. Substitute VA equals square root mu s is 1.2, G is 9.81, and RA is 32.2 meter. And when you solve this, you get your VA as 19.5 meter per second. This is the velocity with which the car moves along path A. We do the same thing for path B. We write VB equals square root mu SGRB, which is square root 1.2 times 9.81 times 10.3. And when you solve this, you get your VB as 11 meter per second. So we found our velocity. After we found the velocity, we need to find the path length or the distance each car covers moving along the red path and the blue path. Now, when the car is moving along the red path, you see the red path is a semicircular curve. So if I want to find the distance covered along moving from A to A prime, I just need to find what is the circumference of this semicircular curve. What is the perimeter of this semicircle? We know that when we move around a circle, the total distance that we cover is equal to the circumference of the circle, which is 2 pi r. And when I'm covering half of the circle, the total length that I will move will be 2 pi r divided by 2, which is just pi times r. So when I'm moving along the red path, the total distance I'm covering along that path is just LA equals pi times RA. Because the distance from A to A prime is just the semicircular region of the arc. And we can calculate this region by taking half of 2 pi r, which is just pi RA. We substitute and calculate the value of LA, the distance covered by car moving along the red path, pi times 32.2 meter, and that is equal to 101 meter. Now we do the same thing for the blue path. The only difference in the blue path as shown over here is we are not just finding the distance we move along the curved path. When going from B to B prime, you're covering a straight line path, then the curve, and then again the straight line path. So I need to find what is the distance we travel along the curve plus what is this distance along this path, which we will call as D. This region as shown in the big figure between these dotted lines. This is the distance D that I need to find. Now this distance D we can calculate by taking the difference of the radius of the two circular paths, the radius of the outer circle minus the radius of the inner circle. So my D is going to be RA minus RB. And when I'm moving along the curve, I need to take how much distance I move along the semicircle plus twice the distance D because we are moving along the path D 2 times. So I write my length B covered for the blue path will be equal to same as before pi times RB to cover the semicircular region plus 2 times the distance D, which is 2 times RA minus RB. And then when you solve for this, you get LB equals pi times 10.3 plus 2 times RA, which is 32.2 minus RB, which is 10.3. And when you solve this, you get LB equals 76.2 meter. Now, once I have the velocity values as well as the path length, I can calculate the time taken for the red path and the blue path. And we will find the time by just dividing the distance with the speed. So time for the red path will be the length along the red path, which is LA, divided by its speed, which is VA. So LA is 101.0 and the speed is 19.5. And when you solve this, you get the time taken along the red path to be equal to 5.20 seconds. We do the same thing for the time along the blue path. T for blue will be the distance traveled along the blue path over the speed. The distance traveled is 76.2 and the speed is 11 meter per second. And that gives you the time along the blue path to be equal to 6.92 seconds. So you see, even though the blue path is shorter than the red path, the time taken to go from point A to A prime is smaller than going from point B to B prime. This is why the drivers in the Formula One racing follow the path A instead of going along the shortest path B.